Okay, this first problem asks us to write the sequence in both a recursive and an explicit form. So this appears to be arithmetic. It looks like it's subtracting 2 each time. So for a recursive form, we would write a sub 1 equals whatever the first term is. And then for successive terms, we would say that the next term is equal to the previous term, and then you perform the difference. So here in this case, it would be a subtract by 2. As far as an explicit form, the way I personally like to work with this is I like to say that a sub n, whatever the nth term is, it's going to be equal to, let's see, since it's going down by 2, I'm going to have a negative 2 slope because it's like a linear graph. So negative 2n, and then if I were to do negative 2 times 1, I get negative 2, but I'm supposed to get 12, so I'll just add on 14, and that's the explicit form you can check. Okay, second one is write a sequence in both recursive and explicit for this particular one. So we're going from 1/3 to 5/3 to 9/3 to 13/3. So we're always adding on 4/3. So my recursive form would be my first term is 1/3, and to get to my next term, I will take the previous term and add on 4/3. For my explicit form, I will notice again that the change, the common difference is 4/3. So I'll put 4/3 n. And if I did 4/3 n, 4/3 times 1 is 4/3, but I'm supposed to get 1/3. So I'll subtract 3/3 from that, which means 1, and that's going to give me a good explicit form. Okay. For this problem, find an explicit formula for an arithmetic sequence if you know that the first term is 5 and that the common difference is 7. Okay, since we have a general form for these, an equals a1 plus n minus 1 times d, I can just say that a sub n is going to be equal to the first term plus n minus 1 times the common difference, which is 7. That's far enough technically. It doesn't say to simplify, but I do like to do a little bit of simplification. So n times 7 is 7n. We'd be minusing 7 from the 5, so we would be subtracting 2. So that would be a simplified version of that explicit formula. And finally, this one wants us to find an explicit formula for an arithmetic sequence knowing that the first term is 5 and that the fourth term is 15. So since the fourth term is equal to the first term plus n minus 1, 4 minus 1 is 3, times d, that means that a sub 4 must be equal to 5 plus 3d, and a sub 4 was said to be 15, so I can use this to solve. Subtract 5, divide by 3, and there's my common difference of 10/3. So my explicit form would be an equals the first term plus n minus 1 multiplied by that common difference, which we find to be 10/3. And again, if you want to do a little simplification here, let's change this into a 15 over 3 plus 10 over 3n minus 10 over 3. And so you might wish to call this 10/3 n plus 5 over 3, which is another way of writing that explicit form.